Road surface marking is any kind of device or material that is used on a road surface in order to convey official information. They are commonly placed with road marking machines, also referred to as road marking equipment or pavement marking equipment. They can also be applied in other facilities used by vehicles to mark parking spaces or designate areas for other uses. In some countries and areas, France, Italy, Czech Republic, Slovakia etc., road markings are conceived as horizontal traffic signs, as opposed to vertical traffic signs placed on posts. Road surface markings are used on paved roadways to provide guidance and information to drivers and pedestrians. Uniformity of the markings is an important factor in minimizing confusion and uncertainty about their meaning, and efforts exist to standardize such markings across borders. However, countries and areas categorize and specify road surface markings in different ways. White lines are called white lines: mechanical, non-mechanical, or temporary. They can be used to delineate traffic lanes, inform motorists and pedestrians, or serve as noise generators when run across a road, or attempt to wake a sleeping driver when installed in the shoulders of a road. Road surface marking can also indicate regulations for parking and stopping. There is continuous effort to improve the road marking system, and technological breakthroughs include adding retroreflectivity, increasing longevity, and lowering installation cost. Today, road markings are used to convey a range of information to the driver, spanning navigational, safety and enforcement issues leading to their use in road environment understanding within advanced driver assistance systems and consideration for future use in autonomous road vehicles. Mechanical devices may be raised or recessed into the road surface, and either reflective or non-reflective. Most are permanent, some are movable. Cat's eye, invented by Percy Shaw in the 1930s, cat's eyes equip many major routes in the British Isles. They consist of 4 reflective lenses mounted in a durable white rubber housing, 2 facing fore and 2 facing aft. The housing is mounted within a cast iron shoe, which the rubber housing sinks into when driven over. This provides protection from snow plowing and allows the lenses to be self-cleaning. They pass a rubber blade when depressed. The lenses are available in a variety of different colors, mainly white, yellow/orange, green, red, and blue. Bots dots, low rounded white or yellow dots, named for the California Caltrans engineer Albert Botts, who invented the epoxy that keeps them glued down, are one type of a mechanical non-reflective raised marker. Generally, they are used to mark the edges of traffic lanes, frequently in conjunction with raised reflective markers. Botts dots are also used across a travel lane to draw the driver's attention to the road. They are frequently used in this way to alert drivers to toll booths, school zones, or other significant reduction of speed limit. They are normally only used in warm climates since snow plows usually remove them along with the snow. Rumble strips are commonly used for the same purpose. A rumble strip can be a series of simple troughs, typically 1 cm, 0.4 in, deep and 10 cm, 4 in, wide, that is ground out of the asphalt. Other alternatives, similar to the Botts dots, use raised strips, painted or glued to the surface. A specific form of raised strips using thermoplastic is called profile thermoplastic markings. The markings are created by fusing thermoplastic to the pavement and create alternating elevation and recession pattern. This can be done as inverted profile markings or raised profile markings. Inverted profile markings are created by pressing a cog rolling over the markings while they are wet to make them corrugated. Raised profile markings are created by extruding extra thickness of thermoplastic at a specific interval to create bumps. Raised profile markings are sometimes known as convex traffic lines. Uses of rumble strips can be across the travel direction, to warn of hazards ahead, or along the travel direction, to warn of hazards of not staying within a specific lane. Their main way of function is creating a strong vibration when driven over that will alert a driver to various upcoming hazards both by sound and the physical vibration of the vehicle. A musical road uses specific patterns of these vibrations to produce music. Reflective markers are used as travel lane dividers, to mark the central reservation, median, or to mark exit slip roads. Incorporating a raised retroreflective element, they are typically more visible at night and in inclement weather than standard road marking lines. The color of markers varies depending on the country of use. Freeways in the United States often use reflectors manufactured to appear white to drivers proceeding in the proper direction of travel, and appear red on the reverse to warn drivers that they are proceeding against the proper direction of travel, creating a danger of a head-on collision. Reflective markers are also referred to as raised pavement markers, road studs, and sometimes, generically, in the UK and Ireland as cat's eye, although this name refers to one particular brand of product. These markers can be used for other purposes such as marking the locations of fire hydrants, blue, or at gates of gated communities to indicate that emergency service vehicles have a code or device that allows them to open the gate. In the United Kingdom and elsewhere, raised markers are used to mark pedestrian crossings to assist the blind in crossing streets. In colder climates, reflective markers may be installed below ground using an elongated narrow triangle, cut into the road surface that allows the device to be installed below the road surface. Newer technology allows these to be placed above ground with snowplow rails that attempt to protect the reflective components from the snowplow blade. Sometimes the result of roadwork may leave visible marks on the pavements. An example is the dowel bar retrofit process to reinforce concrete slabs in order to extend the life of older concrete pavements. The completion of the process leaves a symmetrical pattern of dash marks on the roadway, as if there were an associated meaning to the pattern. When there are many of them along the roadway, motorists may interpret the marks as an unknown form of mechanical markers or strange road surface markings. When roads are under construction and the lanes are shifted laterally, those marks may interfere with temporary lane markings. As the marks from the dowel bar retrofit are not intended to be any form of road surface markings, the responsible agencies try to make these marks less visible to the motorists. Some municipalities require contractors to install utility repair tags to identify responsible parties of the patches that fill utility cuts. The color-coded tags are visible on the road surface. Paint, sometimes with additives such as retroreflective glass beads, is generally used to mark travel lanes. It is also used to mark spaces in parking lots or special-purpose spaces for disabled parking, loading zones, or time-restricted parking areas. Colors for these applications vary by locality. Paint is a low-cost marking and has been in widespread use since approximately the early 1950s. Paint consists of three main components: pigments, resins or binders, and water or solvents. Pigments are finely grounded materials that give out colors or block out the surface beneath it. They may contain other materials such as UV stabilizer, and fillers which bring out the color pigments, color yellow, white, orange, and light blue, to the required level. Resins or binders are the glue of the paint to bind pigment and glass beads together to the road surface. The resins for water-based paints are polyvinyl acetate latex, methyl methacrylate or acrylic resin. The resins for solvent-based paints are linseed or soya oils and alkyd resins. The pigments and resins are mixed with water for water-based paints and solvents for solvent-based paints so that they can be applied onto the road surface. Solvents include naphtha, toluene, methanol, methylene chloride, and acetone. Due to environmental concerns, some jurisdictions may have restrictions on solvent-based paints. Paint is usually applied right after the road has been paved. The road is marked commonly by a truck called a striper. These trucks contain hundreds of gallons of paint stored in huge drums which sit on the bed. The markings are controlled manually or automatically by the controller who sits on the bed. Paint is run through a series of hoses under air pressure and applied to the roadway surface along with the application of glass beads for retroreflectivity. After application, the paint dries fairly quickly. Sometimes the glass beads are mixed in with the paint and applied together. However, a more recommended method is to use a separate gun to spray the glass beads onto the wet paint during the application. Painted symbols, such as turn lane arrows or HOV lane markers, are applied manually using stencils. Painted markings usually last 9 to 36 months. There are some water-based paints that can be applied at double the level of thickness of typical latex paints. This technique can extend the life of the markings. In roads paved with sets, as in Belgian/Italian or Portuguese styles, or cobblestones, markings can be made with white blocks or stones, like marble or other light-colored rocks. This kind of marking is long-lasting, but can be slippery in rain or wet conditions unless surfaced with a matte or rough finish. One of the most common types of road marking based on its balance between cost and performance longevity, thermoplastic binder systems are generally based on one of three core chemistries: hydrocarbons, rosin esters, or maleic modified rosin esters, MMRE. Thermoplastic coatings are generally homogeneous dry mixes of binder resins, plasticizers, glass beads, or other optics, pigments, and fillers. Their use has increased over paints mainly due to the performance benefits of increased durability, retroreflectivity, and a lack of Vox solvents. Thermoplastic markings are applied using specially designed vehicles. Usually, thermoplastic marking mode is applied by machine to coat traffic lines, a free preheating by a device commonly called a preheater. The thermoplastic mix is heated in trucks to about 200 degrees Celsius 400 degrees Fahrenheit before being fed to the application apparatus. This is often a screed box or ribbon gun. Immediately after the thermoplastic has been applied, glass beads are laid onto the hot material so that they embed before the plastic hardens. These beads provide initial retroreflection. As the marking wears during use and the initial beads are lost, the beads mixed with the binder are uncovered, providing long-term retroreflectivity. These can be made exceptionally thick to produce a rumble strip effect. The thermoplastic marking coating sets quickly. The melt adhesion of a synthetic resin makes hot melt paint adhere strongly to the road surface. Additives in the coating paint increases the coating plasticity, improving the anti-settling, anti-pollution, and anti-tarnish qualities. Thermoplastic marking paint is most commonly produced in yellow and white. The white marking paint mainly contains titanium white, zinc oxide, and lithopone, while the yellow paint is mainly heat yellowing lead. In warm climate areas, the thermoplastic markings can last 3 to 6 years. However, snowplows can damage the thermoplastics, limiting usage in cold climate areas. The filling materials of road paint can affect the mechanical strength, abrasion resistance, and hue of the coating film. The particle size of the paint powder influences the flow, sedimentation, and the surface processing. Preformed thermoplastic pavement markings, sometimes called tape, but not to be confused with preformed polymer tape, are thermoplastic cut into the final shapes by the manufacturers and ready to position onto an asphalt or concrete pavement surface. Preformed thermoplastics are put into place on the road surface and applied using a propane heat torch. Some models require heating the road surface prior to the placement of the preformed thermoplastics. These markings are used primarily because of their durability and cost-effective service life. Since the plastics are melted into the surface, they are not easily damaged by snowplows. Typically, the preformed thermoplastic markings can last 3 to 6 years. The most common applications of preformed thermoplastic pavement markings are found at intersections as transverse markings such as stop lines, legends, crosswalks, arrows, bike lane symbols, and accessibility symbols. Commonly referred to as tape or cold plastic, this product is heavy-grade material with reflective beads embedded in the plastic. It is commonly used to mark crosswalks, stop bars, and traffic guidance such as turn lanes, HOV lanes, train crossings, pedestrian crossings, taxi lanes, bus lanes, and bike lanes. There are two ways to apply tape. Overlay, the application being laid over the surface of the pavement. Using industrial-grade rubber cement, once the tape is combined with the pavement, it should last 3 years. Major obstacles to estimated life are snowplows, salt, and misapplication. Inlay, the tape physically becomes part of the asphalt. Using the heat generated in the paving process, road workers lay special tape on the asphalt in the hardening process, and rollers compress the two together. The life of the preformed polymer tapes can vary based on the applications. If applied correctly, they can last between 4 and 8 years. However, there have been cases where tape failures start soon after the installation. Conditions that may contribute to tape failure are cold weather at installation, surface preparation, and workmanship. A technique to minimize the tape being scraped off by snowplows is sandblasting a groove into the surface and fixing the tape onto this groove. This technique diminishes the advantage of low labor cost of the tapes. The preformed polymer tape markings are slippery when wet, especially in large sections such as crosswalks, and caution should be used due to poor wet traction. Epoxy consists of parts, a pigmented resin base and catalyst. The two parts are mixed in a specialized truck for epoxy marking application. The epoxy is then heated prior to spraying onto road surface. Retroreflective glass beads are applied using a separate bead gun behind the epoxy spray gun. Typically, epoxy markings last about 4 years. Epoxy has been in use since the late 1970s and has gained popularity over the 1990s as the technology has become more affordable and reliable. This material competes directly with plastic with respect to usage and cost. Glass beads composed of soda-lime glass are essential for providing retroreflectivity in many kinds of road markings. Retroreflectivity occurs when incident light from vehicles is refracted within glass beads that are embedded in road markings and then reflected back into the driver's field of view. To install glass beads, line painters often use hand dispensers or glass bead dispensers. No matter what tool they use, the line paint should be wet when applying the reflective glass. It is important that the reflective glass beads is not mixed with paint. They must sit on top of the paint to catch the light from the vehicles. In the United States, the demand for glass beads has led to importing from countries using outdated manufacturing regulations and techniques. These techniques include the use of heavy metals such as arsenic, antimony, and lead during the manufacturing process as decolorizing and fining agents. It has been found that the heavy metals become incorporated into the bead's glass matrix and may leach under environmental conditions that roads experience. Abrasion may dislodge these beads from the road marking itself, and the reaction of these beads with an aqueous environment vastly accelerates their decomposition and heavy metal release. During both routine road marking removal and harsh environmental conditions, these glass beads can degrade and leach incorporated heavy metals. There are other, non-toxic metals that can achieve the same results. These may include zirconium, tungsten, titanium, and barium. Negative impacts to road surface. Non-mechanical markers are found to contribute to the deterioration of asphalt concrete road surface courses. The paint and tape markers can cause the road surface to crack, and in more severe cases, the markers contribute to road surface raveling, a process in which the aggregate particles are dislodged from the road surface, causing the surface texture to become deeply pitted and very rough, or potholes. This type of surface damage can be found exclusively underneath the pavement markings such as lane markings and turn lane arrows. There is no definitive explanation of the relationship between pavement markings and surface deterioration, but there are several hypotheses. One is that water vapor may have been trapped underneath the road surface markings, causing the debonding of asphalt binder from the aggregate materials. Another hypothesis is that the reflectivity of the markings may create differences in solar heating and thermal expansion strains between the areas with and without markings. Small flaws caused by differential strains may be combined into longitudinal cracks along the markings. There are certain surface treatments that can make the road surface less susceptible to this type of distresses, such as slurry seals and stone mastic asphalt. Pavement marking removal system using high-pressure water blasting. There are several methods of marker removal. Blasting. There are many materials that can be used for blasting on the road surface to remove markers. These include water, sand, crushed glass, dry ice, and soda. High-pressure water blasting method uses 30,000 psi, 210 MPa, water jet system on a truck equipped with vacuum heads to blast out the markings and suction up the water and debris back to the storage area of the truck. The method can remove markers at speeds of 2 miles per hour, 3.2 kilometers per hour. The only disadvantage of this method is that it can only be operated at above the freezing temperature. Sand blasting methods utilizes high-pressure air and a nozzle to blast sand aggregate. This method produces a lot of debris. It requires a vehicle to supply the aggregate sand and another vehicle with debris collection system. Sand blasting can cause the pavement surface to be polished, causing surface scars and ghost marks due to the contrast between the blasting and non-blasting areas. Soda and dry ice blasting are similar to sand blasting with reduced effects in surface scarring and ghost marks, but the process is slower. Hydroblasting is a combination of water and sand blasting operated at the pressures up to 10,000 psi, 69 MPa. However, the method has been replaced with high-pressure water blasting. Grinding. The grinding method is to use rotating abrasive surface against the markings to break them up. It can be in the form of grinding, milling, or flailing. One grinding head uses orbital abrasive disc similar to an orbital sander. Another grinding head uses spindles with teeth. Another type of grinding use a drum of discs with teeth stacked side by side. Surface scarring is expected with all grinding techniques. Burning, high heat and flame can be used as methods of marker removal. In the hot compressed air method, a combustion chamber with a mixture of high-velocity air and propane can emit heated gas with temperatures of 2,400 degrees Fahrenheit 1,320 degrees Celsius. An excess oxygen method uses propane and oxygen mixture ejected out of a nozzle to create an external flame, and additional oxygen is added to the flame to create temperatures in excess of 4,500 degrees Fahrenheit 2,480 degrees Celsius. The flame is applied directly to the markers. In both methods, care is to be taken not to melt the asphalt road surface. Other methods, laser has been used in an experimental phase to remove markers, but the process is slow. A method of chemical applications to the markers to break them down is also used. This method requires pressure washing to remove the markers. In certain cases, masking the markers is preferred. Marking material is used to cover the markers or a portion of road surface. The color of the masking material is made to be similar to the color of the road surface. Some markings, such removable preform tapes, are applied as a temporary marker removal measure. The most expensive method is resurfacing. This method is used only in limited cases. Thermoplastic road marking paint is a solid powder at room temperature. The thermoplastic paint is melted in a specialized machine called a thermoplastic heater mixer, before being transferred into the paint tank of a marker. Larger marking machines may have internal heater mixers. The molten coating is introduced into an insulated marking bucket. The marking bucket leads to a marking shoe that applies the material. Moving the shoe forward pulls a thin layer of paint onto the road. The thickness of this layer is controlled by the gap between the marking shoe and the road. A specialized attachment can spread an even layer of glass beads onto the paint as it is deposited. Air spray is a method of marking that uses compressed air to spray the paint onto the road surface. The finely atomized paint produces a thin and smooth layer, but the rebounding airflow causes significant paint scattering. This produces somewhat sloppy markings. High-pressure airless spraying uses a high-pressure airless pump to spray the paint. The atomized paint is not so fine and smooth as air spray, but there is no high-speed airflow to scatter any rebounding paint. The marked lines are neat. This method can apply paints of high viscosity, and apply relatively thick layers in a single pass. Other equipment is often used with road marking machines. The main auxiliary equipment includes thermoplastic paint preheaters, hand-push pre-markers, and road marking removers. Thermoplastic paint preheater is used to melt the solid powder coating into a viscous liquid, providing a steady supply of paint to the marking machine. Pre-markers are used to draw a field sketch in advance to avoid faulty marking. Road marking removers are used to remove old or incorrect markings. Large self-propelled machines usually do not need any support equipment, as equivalent functionality is built in. Traffic cones are sometimes used to separate high-occupancy vehicle lanes from regular traffic lanes. They are also used in areas where lanes are used at different times for travel in both directions. These cones have shafts that drop into holes in the road surface. A good example of this type of use was the Golden Gate Bridge in San Francisco, before they switched to a movable barrier system. Removable tapes can also be used in road construction sites as temporary markers. The tapes can be placed to shift the lanes, and black tapes can be used to temporarily black out the existing markings. At the end of the constructions or within 6 months, the tapes can be pulled out of the surface without using heat, solvents, or machines. Thank you for watching for this video.